Hi and welcome to another MicroTasker Shorts video. In this video we're going to be taking a KL27 and we're going to be using its UART in free running DMA mode for reception. This means no interrupts. To show and explain the operation, I'm using Visual Studio and the simulation. In the file config.h I search for the KL27 which I want to activate for our tests. I'm activating it and I'm removing any defines which were previously there. Now I go to the hardware configuration and I enable DMA reception and also the option for free run mode. Then in the application directory I open the application file. I enable the free running reception reference and now I can build. Once the build is completed we can take a look at what the code actually does. So we're going to start with the breakpoint in the open routine and we're going to let the code run. I'm single stepping to check the channel. This is channel 0, a low power UART in the KL27. Now I continue stepping and we see that we have a reception queue size of 80 hex, which is 128 bytes. We'll see in a minute why that's important. For the KL processor, we set a DMA mode of UART DMA, which enables essentially the free running DMA, but we also set up UART modulo. Now the reason for the modulo mode is that the KL's DMA requires modular based reception buffers for continuous operation. We'll see this in a few minutes. And the other thing which I do is I set the application task to a polling mode. The reason is we're going to be polling the reception buffer. Now this is not to be confused with polling the UART itself. This is polling the software buffer where the UART reception data will be stored to by the DMA module. When we open the UART, it will give us a modular aligned buffer with the size of 128 bytes, and it will also configure the DMA mode which we requested. So we can get an idea of the work entailed. I've set a breakpoint in the driver where the reception buffer is enabled. Now we can see that what takes place is that we recognize first that we have a low power UART and that it's being enabled for the first time, and then we call a routine enable RX and DMA. Now in this routine the main feature is the call to the config DMA buffer. Config DMA buffer is a very powerful routine deep in the MicroTasker code which allows very simple configuration of DMA channels for such activity. Now what it's doing here, it's passing the information about the size of the buffer, its location and so on, and also quite importantly the location of the data register of the UART. I'm not going to go into this routine, but we're going to let it continue and we're going to start the DMA and then we're going to enable the reception with the interrupt or DMA operation. So now we can let the code run. Now what we've just seen is that we come back in this routine, in fact all of the time. This is the polling which is taking place. So I'm going to remove this breakpoint, but we're going to quickly look at what happens in the polling case. Now it's the application task which is in a free running mode as well, and whenever it's not doing anything else, it will just be checking to see whether we have any reception. The way that it works is by using this local call check free running DMA reception. Now this will be a little bit different on the KL27 compared to, for example, a K64, which has a different DMA controller in it. So when we look in this routine, we can get an idea of what it's doing. First of all, it's detecting the channel in the DMA controller which is being used, and then it's looking at whether after taking a snapshot of the present DMA pointer, whether we've actually had any more reception in the meantime, and if we did, which we won't have at the moment, it would then increase the amount of characters which it reports as waiting in the reception buffer. So I'm going to let this thing run now in the simulation, and at the same time we're going to look at a terminal emulator which is connected to the simulation, and we can see here that if I start entering some characters, we get reception, and we get also operation, which basically gives us a good idea that everything's working well. Now, before seeing the same operation on the hardware, I'm going to give you an idea of actually how the DMA operates, so that the advantages and the potential disadvantages can also be appreciated.